Our 2 o'clock talk is Machine Learning with Xamarin.Forms with Dan Hermes. And Dan is the author of 2 books about mobile application development using Xamarin. He's a Xamarin MVP, a Microsoft Regional Director, and MVP, and founder of Lexicon Systems. He helps developers create great mobile apps and leveraging IoT and AI, helps businesses develop a winning mobile strategy. Dan's firm has advised on dozens of successful business apps in healthcare, retail, government, education, finance, transportation, biotech, and others. That's a lot. Xamarin mobile projects include cross-platform app for Thermo Fisher Scientific, which won a W3, a Davey Award, and was a finalist for a Xammy Award, as well as a medical app used by over 40,000 surgeons. He speaks at conferences, universities, and user groups. Dan develops Azure and Xamarin course curriculum for Microsoft and edX. And recent speaking engagements include IBM InterConnect, Xamarin Dev Days, Microsoft Azure Day, and Microsoft Ignite. He's written articles recently for IBM's Mobile Business Insights and Microsoft's MSDN magazine. He's the author of a best-selling book published by Apress entitled Xamarin Mobile Application Development. His book's recommended reading at the Harvard Extension School and the first of its kind at the MIT Library. The book offers guidance to developers and companies building cross-platform apps using cross-platform mobile apps in C# using Xamarin. His latest book was released this year entitled Building Xamarin.Forms Mobile Apps Using XAML. So let's welcome Dan Hermes.
Thank you for the great introduction, Stan. I really appreciate it. I actually hail to a certain degree from the Northern Virginia area. I went to college down there and got my start in computer science down there in Herndon and Sterling for a number of years. So it's great to be back in a certain way. I'm here from Boston today, but it's great to be back into the ecosystem there in Nova. So today we're going to be talking about machine learning. There's a few great talks on ML I can see on the docket today. This particular one is going to have to do with TensorFlow Lite, and doing it in a mobile app using Xamarin.Forms. The first aspect of ML is going to be getting data. And this is all about pulling the information that we need in order to train the model. And then we need to clean and prepare them and manipulate this data. We can't just feed it dirty data. We need to be able to make sure this data is clear. Any kind of teaching situation, you want the examples to be crystal clear. You know, for people and kids, it's the same as machines. They like crystal clear demonstrations, unless you're trying to teach them about ambiguous or challenging situations. Then you fuzz it up on purpose. But you don't just take fuzzy data. And that just gets in a little bit to the sort of garbage in, garbage out conversation we were hearing in the previous talk. And I'll get into a little bit more about how we can keep things clear and not garbage. So after we have our data and we have it cleaned up, then we train the model with it. Once we train the model, then we have test data that we use to validate and check. And we come up with statistics as to how well that training went. And then we sort of do a repeat cycle where we continue to pull in new data, we manipulate that data, we train again, we test again, we look at the statistics, and then we keep improving the system until we have something that we're happy with and we have a model that we feel that we can use for either testing or production. There are a lot of different approaches. There are a lot of different ways to do machine learning. I'm not going to go into all of these, but I want to give you some notion that there are many, many different ways to approach machine learning. There's everything from decision trees to vector machines, regression, just straight up arithmetic regression. Something called Bayes classification is very common and very useful. Markov models. The one I'm going to be going into is neural networks. And that's gotten a lot of attention these days just because there's been so much recent success with it, and it's really easy to build one. And so what are these things? What are models? They're the machine's representation of reality. Say in Google Maps, that's constantly creating a model of your driving patterns, of all the places you like to go, what times you like to go to those places. Netflix is constantly creating a model of your viewing habits, the types of things that you watch, the times at which you like to watch things, the categorization of the television shows and the movies that you like to watch, and then it connects those to other people and comes up with sort of general classifications of types of viewers and builds models that way. So Netflix is constantly using us to build models. Machine learning is the training of that model. And so how do we make these things? They're designed and optimized, as I talked about before. To the right here is a sort of a zoo. They call it a network zoo of different types of neural networks. Humans or computers can train models. That is, we can train them by giving them data that's labeled, or we can teach them to train themselves, which is called unsupervised learning. Data is assigned categories called labels, and I'll show you exactly how that works in just a minute. And some of those examples, say in Netflix, is movies are labeled horror, drama, comedy, etc. Those are very high-level labels. Neural networks have more layers and nodes than some of the other arithmetic approaches. So drilling down further, we're not just doing any ML, we're doing visual cognition. And so in this situation, a visual learner, that is the system, sees an image. It analyzes that image using its model, it categorizes that image, and then it requires many images in order to teach itself well enough to be able to make predictions and make decisions. When you teach it well enough, it could then categorize things using your labels into, say, a category like fruit. A machine learner can identify a fruit. If you further train it, a machine learner can then identify a certain kind of fruit, such as an apple. So let me first do a quick app walkthrough of the mobile app, and then I'm going to talk about how we're going to train the model for that app, and then we're going to talk about how we use the model in code. All right, so we're within Visual Studio, and I'm running a Xamarin.Forms application. And this Xamarin.Forms application utilizes Tensorflow Lite. There's a NuGet package of Tensorflow Lite in this app. And the way the app works is you pick a photo. Now, the most fun way to use this app is actually when you have a physical device, is to just point it at your hand or point it at somebody else's hand when they're making a hand gesture. What this app does is identifies hand gestures like thumbs up or A-OK or wave, things like this. And so it's most fun when someone can just do something like that. You point the camera at them, you take the picture, and then it tries to identify it. But since we have to use a simulator, we're going to use the pictures that are here on the phone. So here they are. And here's some pictures that I've taken. And so I'm going to click thumbs up. And it's going to chew on it for a second and compare it to the model and see whether or not it decides, okay, well, it doesn't get a match. Well, let's see. Well, what happened there? Let me try it one more time. Let me try this thumb. And then choose on it again and compares it to the model. There we go. Okay, so the first thumb, it's not quite trained well enough to be able to match all thumbs, but it's trained well enough to be able to match some thumbs. Well, I mean, does it really know thumbs? Does it know other things too besides thumbs? Let me go ahead and give this a shot. Let me try the A-OK here. And it chews on that for a second, and then it identifies that as A-OK. Okay, well, this is not doing terribly. This is not doing badly at all. I'm gonna pick one more. And I'll go ahead and pick the fist, the power gesture here. And it chews on that, and boom, there we go. It knows that that's the fist. Now, I haven't actually trained this particular model on one of these gestures, and that is the wave gesture. So let's see what it does with it. It knows that it doesn't know the wave gesture. That's actually a good thing. Okay, so that's how the app works. Now, what I'd like to do next, that we just chose the image, it interpreted it and classified it, it predicted the result, and this brings us over into the utilization of the data and the training of the model. Okay, I don't think this video is going to work with this setup, so I'm not going to try that. I'm going to bring us right over into the training of the model. So I'm now in something called customvision.ai. Now Microsoft has any number of ML options, and it comes up with a new one every few months. Actually just acquired a company called Loeb that does it, and we'll be hearing more about that, I expect. So a little later in the presentation, I'm going to show you their whole ML ecosystem, ML.net, everything else, and then you can start to choose for yourself which one of these work. But for me, all I wanted was to train up a model really quickly using vision cognition, and they have a tool called customvision.ai that does this really well. You go up, you sign up, you log in using your Microsoft login, and then you create a project. And make sure you create a project that is compactable. There's an option for regular ones, and then there's compactable ones. Make absolutely certain that you pick the compactable ones, or this isn't going to work for you. And so you can see some of the images I've already uploaded. These are victory signs. And so if I want to upload more images, you know, I can go and upload some more of some thumbs up. And then I'm going to enter a tag. And this is really important because this helps to train the app. This helps to train the machine learning application, that tag, because then it knows, well, those are thumbs up. And I upload those. And then what you do, and this is really dumb, simple, easy, and in a few minutes we'll talk about what it's actually doing, but you just click the train button and you go quick training, and it then goes for it. And this takes a few minutes, but it will then churn through this and churn through all the images actually that I've already put in there, and create a new model based upon all the images that are in there already. And then it'll give us some statistics based upon how accurate it thinks things are. And historically, ML training programs think they're a lot more successful than they are. Just something to keep in mind. So while it's chewing on that, I'm going to head back over into the code. So the first thing we have are the labels that I used. And here we have AOK and peace and power and thumbs up. And you notice that wave isn't there. I use that for training some of the other models, but not this model that we're using right now. But these are the 4 labels, and you've already seen all 4 of these working. So we know we've got something going. I'll open up the Solution Explorer real quick, just so you can see the structure of the project. This is just sort of a standard Xamarin.Forms project. I have the iOS project unloaded. The Android project is where a lot of the action happens, as well as the Xamarin.Forms project. So let's go to the XAML in Xamarin.Forms. I'm going to go to main view. And that's where we have our buttons, take photo and pick photo. And those are bound to commands, take photo and pick photo. And then we go over to our view model. And we have our take photo and our pick photo. And I'm going to stick to pick photo right now because that's what we're using. And then it awaits handle photo. And then over into handle photo, it then starts managing the classification. And here's where it goes and calls classify, which I'll move to in just a second. And once classify is completed, then classification completed will fire, and then it'll do this final item here and move to that next page, which says that it's a match or not a match. So let's go to classify first. That's over in TensorFlow classifier, which is in the Android project, by the way. So that's an important little detail. Now, I'm not going to go through this line by line. I'm going to hit the top items, which is, let's see. We're going to set up an interpreter, and we're going to do that using Xamarin.Tensorflow.Lite.interpreter, and we're going to pass in our model, and our model is passed in using getModel, and getModel just pulls in this model.tflite, and that's the model that's going to be created by our process that's running in the background that we kicked off over in the browser. Let's see how that's doing. Well, it's still training. Okay, well, when this is done, then what I'm going to do is click this export button. And when I click this export button, it's going to give me a model. And that's going to be the model file that I got right there. So we're then pulling that into a mapped byte buffer and doing a few things to it, which aren't really that important. The most important thing here is that we're then going to do interpreter.run and run that interpreter. And then we're going to pass in the photo that we want to compare to that model. And that's this byte buffer, get photo as byte buffer. And there it goes, in it goes. So we queued up the model and we queued up the photo, and we're then going to run the interpreter, and we're going to run this thing and let it go. And it's going to return a result back to its calling routine and fire classification repeated. And now we're down to classification repeated. And what we want to know is the probability of success high enough that we think we have a match? Now, just to let you know, the one thing about this model is that it doesn't use very many images. We'll get to see exactly the images in just a minute, but it's 140 images. That's a pittance. You want to use at least 1,000 images, preferably 10,000, if you really want a smart model. If you want something running up in the 80s and 90s, 80 and 90% probabilities, you need thousands of images. But I didn't want to put in thousands of images. I just wanted to show that with a phone, using your hand up against a wall, that you could train up a model well enough to write an app that would work. Then that was my requirement. And I succeeded in doing that, but part of what I'm going to do is the probabilities, most of them run in like, if it's correct, they run like 45 or 48. And so if it knows it doesn't have a match, you'll get a 0.1% or a 3% or something. But if it's over 40, you probably have a match on one of those 4 labels. And so when you get a match, it's going to label the tag name, you know, A-OK, thumbs up, whatever it is. And then I have images for each of those 4 that are just stock images that you saw. And then if there's not a match, we get that big red circle with a slash. All right, I'm going to stop there at this point. I don't know, Stan, can I take questions at this point? All right. I'm going to take that as a no, not yet. Let me run back through the app real quick. So here we are again. We're in main view.xaml. We pick photo. and then we're picking from the local camera gallery. And we pick the fist. It spins up an interpreter. It runs it against the image, against the model, and it tells us that it knows that that's a fist. That means that the probability was higher than 40%, and that it has a tag name of fist or power.
So I just wanted to, I don't see any questions just yet. I checked the Discord as well. There was a note that I think the audio problem may have gone back a bit. So if there's anything before where you started that you wanted to touch back on again, but I think you started at a spot that, you know, there was continuity from there forward.
Do you think I should go back?
I don't know how much before, because I don't know how much before that slide was integral, but I think we don't seem to have any questions, so I think everything since then has been has made sense to people.
Okay, all right, very good.
If not, they are welcome to post a question in Discord or in the Q&A here, and we will let you know.
That's great. All right. So as I talked about before, the machine learning landscape at Microsoft is quite broad, and it's growing every day. They really are taking this seriously. And so for a while, all we had were Azure Cognitive Services. And if you use those are great if you're just getting started and you just want to know what cognitive services are, because these are what we're trying to build in most cases. So they give us ready-made, built visual, text, speech, you name it. They have about 6 of them. They have a search. Try that first if you haven't done any of these, because you can just go up and play with them. That they have the interface right in the browser, and you don't even have to run any code. It shows you the JSON that comes back from the service. It's really cool. So Azure Cognitive Services, recommend that. Azure Machine Learning is a little more sort of industrial strength. This is for people who already know machine learning, but they just want a way to manage it a little bit better in a sort of a corporate kind of enterprise way. And that's what people are using Azure Machine Learning for. And then ML.NET, the next talk is going to be about that. And that's for anyone working in .NET who wants to be serious about ML. It's pretty high level. It's more high level than TensorFlow, for instance, but it's less high level than what I just showed you for Custom Vision, a little more in the weeds. And then Loeb is a company that they acquired that people can go use the beta, but I don't know that that's really very public yet. And WinML, some people are using. All right, that's the ML landscape for Microsoft. So the ones that we've worked with here are Azure Custom Vision and TensorFlow Lite. Now we've already walked through this. Oh, here's where I wanted to show you. When you set up TensorFlow Lite and bring it in as a NuGet package into your Xamarin app, this is how you do it. You bring up the NuGet manager, you go to browse, you type in Xamarin.TensorFlow, and it'll come up Xamarin.TensorFlow.Lite. Go ahead and this is really the only thing you have to write down. Because without that NuGet, we've got nothing. So there it is. Now, at this point, I'm going to ask a kind of a rhetorical question. Do we want to take the red pill or the blue pill? Do we want to go deeper with ML? that is really get down into what TensorFlow does to build a neural network, or do you folks want to move to Q&A?
So that's going to take a few seconds for them to get that. So we should wait and give them a little bit of a chance to respond.
All right. What we haven't looked at so far is really what is going on behind the scenes with custom vision and with TensorFlow Lite. We've looked at our interfaces that really do package things up cleanly so that we don't have to know exactly what goes on in the training of a model. We don't have to know exactly what goes on in the validation and the testing of a model. And so what I'm proposing here that we do is drill down a little bit and look at those things in Python. And I'm going to go ahead and do it because that's what I want to do.
I have not seen any questions, so I'm assuming do the deeper dive.
All right, I'm going to do the deeper dive. Okay, so I'm now in Visual Code, if any of you worked with this, and I'm in a very particular part of Visual Code. I'm in, or Visual Studio Code, I'm in a Jupyter notebook that's running Python. And so I'm going to run each one of these cells. And the first thing we're going to do is import TensorFlow, import the TensorFlow library. And then we're going to point to the images in that hands directory that we worked with earlier. And now I'm going to set up two data sets. And the first data set is the training data set. And here we can see it found 140 files. Now there were about, what's it getting? What's it actually looking at? Well, it's looking at this. These 5 folders, the AOK, power, thumbs up, victory, and all told, wave, it's looking at 140 images. Now, of those 140 images, we're going to take a validation split of 0.2. That means that we're going to use 28 of those files for validation when it's training. But then when we want to do testing of that, oh, sorry, I jumped ahead, but it's about the same. So that was the data set, the training set with 140 files. The validation set is very similar, except it's kind of the other way around. And instead of using all these files for training, it's going to use these files for just validation. So we have a training set and a validation set. And here we got another total, 140. And then we ask it, here we just want to see the first image to make sure that it's working, and we get an AOK. And here we're going to ask it what are the labels that we're dealing with. And it says AOK, power, thumbs up, victory, and wave. And it gets those from the folder names. It translates those folder names into labels. And then we want to go in and say, okay, well, let's make sure that our data looks okay. Let's look at the validation data. Let's flip through the first 9 images that we've shuffled in the validation set data and see if those look okay. Well, that looks like what I put in there. Some of them are a little stretched, but that's probably just our printing. So that means that our data is looking okay. And so let's look at these images for just a minute. These images are fairly clean images. I picked a very bland background. I picked a background that was different enough in tone from the skin tone that it would be able to distinguish between it. Every once in a while, you'll get a little bit of a plug in the background or something, but these are fairly carefully done images so that there's not things in the way. There's no garbage in the way of these images, so that they could train fairly straightforwardly. And that's probably part of the reason why we had such a success with only 140 images. The success that we did get with 140 images was actually quite astounding. Now that I've seen a little bit more about training, and part of that I think is because the data is so clean. So let's go ahead and jump forward and look at the model itself. Now here we need to import a bunch of libraries to help us build the model, and we're using Keras, if anyone's looked at this. Keras is a library that sits on top of TensorFlow that makes it super easy to build neural networks. Now, in order to build a neural network, you have to learn a few things about the math that goes into it, and you have to learn a few things about the different types of options that you have. But in a nutshell, you're just building layers. And so in this particular one, this is 1, 2, 3, 4, 5 layers. And so a couple of these things are just adding, like this just adds parameters on top of it. This just does some rescaling. The meat and potatoes is here. This is adding a convolutional neural network layer with 128 nodes. This is adding a convolutional neural network layer with 64 nodes. And so these are that neural zoo that I showed you before. These are the columns but with 128 dots, or 64 dots and 32 dots. And this 128 and 64 and 32 and 16, that's a very common funnel structure that people use in neural networks that's often very successful. I think I've been surprised the degree to which building neural networks using ML is more of an art than a science. You really do sort of fiddle until you learn certain things that work better, and you don't know exactly why. Now, when we run this, we get to see that the layers that it's built for us. The easiest way to see it is to look at the parameters to the right. So using that 128 nodes, it comes up with a sort of a combination of connections that give us 3584 parameters. With the 64 connections, the 64 nodes, we come up with connections to the previous layer and to the next layer that give us 73,792 nodes. Or parameters, I'm sorry. These are basically variables. And then the number gets smaller, down to 32, and that comes down to 18,464. All told, we're talking about 9,830,416 parameters. It's not a trivial network. It's simple, but it's not trivial. And then we get into the step where we get to fit that model, meaning train it. And so I say the word fit because it's that is the method name in Keras that we use. And we pass in data set, which is our training data. Remember earlier on we made that training data, and then we pass in val set, which is our validation set that we made earlier. And then we have to pass in a number of epochs. And the number of epochs is really just the number of passes. And I'm going to run this, and it's now going to run 12 passes. And there it goes. It's kind of like a very basic command line graphic-y looking progress bar. And we could say that first one of 12, took 14 seconds. I'm going to skip loss. That's kind of a little complicated for this session. The accuracy was 22%. And then when it validated against our validation set, we got a validation of about 11%. Now that's not very good, but then we look at the next one. Okay, that's the first training pass. Then it tries to train again, and the accuracy was about the same, but the validation comes out as almost 43%. That's a lot better. And then this thing is going to keep running, and I'm going to spoiler for you. When we get to the end of 12, it's not going to have improved very much from what it has right now. 12 pretty much gets us to 43%, which should be a little familiar to you. That 40% that we talked about earlier, the success rate of this thing is only slightly over 40%. And then we do the magic export using, in this case, TF Lite converter. We're using Tensorflow Lite, and we convert it from Keras into a model.tflite file. Now we're not using this file because the one that export out of here is actually a little bit bigger, and it actually is not quite as reliable as the one that came out of Custom Vision. But I wanted to show you how you can make it, because it does work. If we take this and drop it in over there, it works just fine. It's just not quite as accurate. And you can see this is churning through. We're on epoch 8 now, and this is still sticking on about 43%, and it'll stay there. The accuracy has crept up a little bit. Now that's up to 36%. So all told, this is not what you want as an ideal model, but for a demo that works, it's pretty kicking. All right, and then we export it over into our Xamarin.Forms app, and we're good to go. I'm going to show you again where that went. Right here, it went into the platform specific, the Android folder, into the assets. And that's how we connect TensorFlow to Visual Studio. It's just with this one file here, that TensorFlow Lite within Visual Studio can use. All right. So we talked about how to get the data. In this particular case, we're just taking pictures of our hand. We clean it and prepare it, and we didn't do a whole lot of cleaning. What I did was to take pictures of pretty clean data to begin with. Cleaning is a whole process in and of itself and could take a whole class. So just suffice to say that the images that I used here were fairly clean. And then we trained the model, and we did that in 2 different ways. We did that in Custom Vision and in straight up TensorFlow Keras. And then you saw how the testing of the data worked in both. You know, we never really saw how that worked here. Here it is. So the training finally finished over here in Custom Vision, and it thinks that the precision is 100, the recall is 100, and it also, yeah, precision and recall is 100 for both victory and thumbs up. It has a pretty good opinion of itself, like I said before. And then we keep tweaking the model. Here you can't really tweak the model in Custom Vision because they don't give you access to the model. But over here, we could keep tweaking this till our heart's content. But the truth is what this really needs is less tweaking and more data. We need more pictures. So if we really wanted to bring our model to the next level for this particular project, we would take more pictures until we got the pictures up to like 1,000. Once we had the pictures up to 1,000, then we could start looking at things like, well, how did we set up our convolutional neural networks, and did we use the right optimizers, and et cetera, questions like that. Is activation, should it really be softmax? We get into parameters, but until you have enough data, these things don't matter that much. You're going to wind up with 40 no matter what, which is what I found. So we do a sort of a circular improve process where we get our model working as well as we can, and then we let it out into the wild. All right, so that's pretty much it. We trained a model to classify hand signs based upon image data. We used Azure Custom Vision and Tensorflow Lite. And like self-driving cars and banking apps, our hand signs app classifies objects from real life. And that is the end of my talk. I'm happy to take questions.
Thank you very much. And I am not seeing any questions, but we'll give them a couple seconds to go ahead and put those in. Again, we're about 20 seconds behind, so it seems like forever, but we will.
Again, I consult on and build apps, and so if you or your company have any need for help with a Xamarin or mobile app, please drop me a line. Both of those books are available on Amazon.
Let's see. Was there anything you wanted to go back to the first few slides that you had and just reinforce in case the audio wasn't there, which is the feedback that I did get?
I don't know exactly what slides they were, and there's a lot of great ML talks. I think that whatever I was going to cover there was basic ML, and they're going to get it in another talk.
Right. So yeah. That's kind of what my feeling was, is that we started at a good spot, given that we had lost some at the beginning.
They saw all the good stuff.
Yes, absolutely. Yeah. I think that's just about it. I haven't seen any questions. I did see a thank you in our Discord track from Bug Bites, and so I will reiterate that thank you, and I am going to put up a slide for the next presenter, but you are welcome to hang out in the Discord, and if anybody has any questions, just so the people that are listening, that there's a text Discord that's track-data. There's also a voice one that is track data, and if you go in there, you can actually have conversations with people. So if anybody wants to do that, feel free. There's one for each of the tracks, and there's also just a hallway if there's somebody that you see that you haven't seen in a while and you just want to have a conversation, you can do that there. Again, thanks to Dave, and we will see you all at 3.
All right.